Good afternoon, ladies and gentlemen. My name is Faisal Parish from the Global Environment Center in Malaysia, and I'm happy to be your moderator today. Welcome to all of you, both here in Dubai and those who are joining us online. Distinguished speakers, ladies and gentlemen, welcome to this special session at the Land and Drought Resilience Pavilion in COP28 in Dubai. Today we're focusing on a session called Enabling the Triple Win for Tropical Peatland Countries, Advancing Water, Biodiversity and Carbon Measurement. This event is a collaborative event co-organized by the International Tropical Peatland Center based in Indonesia, the Global Peatlands Initiative led by UNEP, together with the G20 Global Land Initiative at UNCCD. Today's session will focus on the critical importance of tropical peatlands and will highlight the need for updated and upgraded emission factors and other information relating to the management and monitoring of peatland ecosystems to enable us to manage peatland in a sustainable way for climate, for water, and for nature. Peatlands are unique ecosystems. They only occupy about 3 to 4% of the land area, but they store approximately 30% of the soil carbon in the world. They are therefore a hotspot of carbon storage, but unfortunately, when we do not manage them well, they become the opposite hotspot of emission. And it's been estimated that up to 2 billion tons of CO2 is emitted per year from degraded peatlands worldwide, even though those degraded peatlands may be only a small fraction of the peatlands globally. Degradation and poor management is leading to very large emissions. Peatlands contain 10% organic matter and 90% water, and that makes peatlands a very key reservoir of fresh water. It's been estimated that peatlands worldwide may store up to 10% of the world's freshwater resources, and therefore they're very critical in the hydrological cycle and in the balance of water resources and in the prevention in coastal areas of saline intrusion and the provision of water supply in the critical times. So we will discuss today the range of issues relating to peatlands, but around the world in the tropics, peatlands are both very critical for carbon storage, but they also provide other goods and services: tropical forest, non-timber forest product, water supply, and many other valuable inputs and materials. But if we do not manage them, and in future we do not restore them, they will be a major source of greenhouse gas. This issue, why are we having a particular linkage with the G20? It's very important to recognize that the G20 countries are very important to peatlands. In fact, almost more than 90% of the global peatland area is found in G20 countries. And therefore, G20 countries are uniquely placed to play a global leadership for the management of peatlands. And peatlands are also very relevant to the issue of land degradation, because degradation of peatlands, as I mentioned, lead to very high greenhouse gas emission and also loss of water resource management, biodiversity, and other factors. So I think it is very good today that we are organizing this event in partnership with the G20 Land Degradation Initiative, so that we can look at how that shared partnership can be explored further in future. When Indonesia was the chair of G20 last year, a special emphasis was placed on the issue of tropical peatland management, and that led to some key points within the declarations made at G20, and we hope that this event will be one way of moving forward the event under the Indian presidency and future presidencies. So this afternoon we have 6 speakers. We're very happy to have Dr. Murali Marukudi, the director of the G20 Global Land Initiative at the UNCCD. We have Dr. Simon Lewis from the University of Leeds from UK, Evossupreme Averti from the University Marian Ngubi in the Republic of Congo, Dr. Francesca Tanur of the Greifswald Maya Center, Ms. Nikin of Sumitomo Forestry from Indonesia, and last but not least, Muhammad Ascari, representing the Director General for Pollution and Environmental Degradation Control of the Ministry of Environment and Forests of Indonesia. Later at the end, we hope to be joined by Mr. Alo De Hong, the Vice Minister of Environment and Forestry of the Republic of Indonesia. So without further ado, I think we need to start the session. We are allocating about 5 minutes to each of the speakers because we want to have enough time for discussion at the end. So I know everyone has a lot to share and many ideas, but we need to have at least some time for discussion. And if we have more information in the presentations, I believe they're going to be made available online. So the details can be there and we can communicate about that. So for the first speaker, again, let me introduce again Mr. Murali Thumarokudi, the Director of UNCCD and the G20 Global Land Initiative. Thank you very much.
Thank you, Faisal, for those opening remarks. And I want to welcome all of you to the Pavilion on Land and Drought, Land Restoration and Drought Resilience. We are extremely delighted to partner with the International Tropical Center as well as the Global Peatland Initiative to organize this session on triple win regarding peatland conservation. I grew up in the tropics in India, and I had never seen a peatland till the time I went to Brunei in 1995, and I was 30 years old at that time. And I saw this black water river coming out of this peatland, and I said there must be really some sort of a horrible pollution coming from, oil industry, because I was flying into Brunei and I saw this black water coming into the, and I said, my God, how can this be allowed? And then I go down, and then I'm driving, and then I see this beautiful Baram River in Malaysia as well as the Kulabalayat River. Then I start to talk to people, and then I understand, okay, this is peatland. Of course, the peatland forests are very different as well. It's unlike the tropical forest which I'm used to, which is full of trees and full of animals, etc. It's a very, very delicate ecosystem. Then comes 1997, and that was an El Nino year, and there was a lot of drought. And we had a situation where we had to think whether the oil industry will have to stop because there is enough water to continue many of our operation. And that's when we realized how much of a water storage buffer these peatlands had. And the river just kept flowing even after the surface was completely dry. And you dig a feet deep, there's water. And unfortunately, it was also the same year, and as many of you from Indonesia and Southeast Asia will remember, that the peatland had massive smoldering of fire, and it engulfed the entire Southeast Asian region. The Singapore airport was closed. Brunei was nearly closed for all sorts of operations. So I have seen this peatland, both its positive aspects as well as the challenges it faces. And one thing which I then understood, based upon my own experience, is that there is such a lack of understanding globally about peatland. Faisal mentioned about the G20 countries. You are right. Between the G20 countries, there is more than 50% of the peatland. But not only that, of 19 out of the 20 G20 members actually have peatlands, or 18 out of the 19 G20 countries have peatlands in them. So it is an issue cutting across all the G20 countries. And when Indonesia took the G20 presidency in 2022, they decided peatland restoration will be one of their priority areas. And we had a number of side events which went with it. And we have been following with the International Tropical Peatland Center, as well as the Global Peatland Initiative, as to how we can augment those messages. How, first of all, we can increase awareness about peatland and its importance. The fact that 3% of the peatland hold 37% of the carbon. People don't know. First of all, you have to know there is peatland. And the biodiversity which you see in the peatland forest is also very unique. It's not the biodiversity seen in other tropical forests. The water holding I already mentioned. At the G20 Global Land Initiative, we are extremely happy to work with these partners. And what we plan to do is to look at best practices of peatland management from Canada, from Asia, from Indonesia, for example, and also from Russia and other places where there are a number of good practices. We also plan to do joint training. We did an event in UK where we brought business and peatland together to see how peatland restoration can be augmented by using business intervention. But more importantly, we have to get the young people involved in this, because only when young people see both the value and opportunity associated with peatland, we can think peatland will have a future. I think it's good to argue in terms of carbon capture. It's good to argue in terms of water buffering capacity. It's good to argue in terms of biodiversity. But ultimately, we have to convince people in terms of the business case as well. In our work in the G20 Global Land Initiative, we take particular interest in connecting with the young people, teaching them about the importance right in schools. When we grew up, our generation, we were connected to land in a very direct way. We saw that if our land was degraded, there was no water security. But now that water is coming in a tap, through a pipe, you don't connect that with the peatland. So that connection between the land and your livelihood has to be reestablished. Not necessarily by, once again, making people drink from the pit. It is about taking them and making understanding that there is indeed a link. We also put particular emphasis on connecting business to restoration. Because only when there is an economic case which is so strong and robust, and in order to do that, we may have to monetize some of the elements, such as carbon, such as biodiversity, such as water security. I think carbon we are getting there in carbon. The new global biodiversity framework will bring the biodiversity fund, and some of the biodiversity can then be monetized. We have to get the same for water. The water security which the peat is offering also has to be monetized. And when we have it, and suddenly restoring peatland, conserving peatland would start to make an economic sense, and business will be really interested. I want to thank the organizers for taking up this very important topic, and looking forward to working with you and looking forward to a very interesting session. Thank you.
Yeah. Okay. Maybe before we continue with the speakers, because we understand at least one of the members have to leave, maybe we can take a group photo with the speakers at the beginning, and then we'll proceed with the rest of the presentations. So thank you very much, Murali, for the presentation and the key opening remarks. Let us proceed to our second speaker, Dr. Simon Lewis from the University of Leeds, who's been one of the pioneers in identifying and documenting peatlands in the Congo Basin. Simon, the floor is yours.
Thank you very much. Yeah, so I've done a lot of work on the central Congo peatlands that straddle between the Republic of Congo and the Democratic Republic of Congo. And as a single area is the largest tropical peatland complex in the world. So this triple win in the measurements for carbon, water, and biodiversity. For carbon in the peat, we have pretty standard methods. It's time-consuming and difficult in the field, but it's relatively straightforward and it's repeatable. We have new methods to extrapolate, to scale up those measurements to whole basins and whole regions. The carbon in the vegetation is also pretty straightforward with standard methods. But what we don't have yet in the Central Congo Basin is an integration of all those flows of carbon. We have those two pools, but we don't have the flows of carbon and the net. And that can come at the local scale from a flux tower and eddy covariance tower. Now, the first one of those is about to be installed in Democratic Republic of Congo in Lukolama, but it will need to be more than one for an area of peatland, 16.7 million a million hectares. And the only way to bound this question of the carbon fluxes at a very large scale that I know of is through repeat aircraft measurements. The same has been done in Brazil, which is how they know the forest is close to a tipping point, because they have 10 years of every 2-week measurements from aircraft, and then you can measure the CO2 and the methane and the nitrous oxide very accurately in a lab from the flash that the aeroplane collects, and then you can bound the net carbon fluxes from these gases across large areas. That needs to be done in the Central Congo Basin. And lastly, missing from the carbon inventories so far are the flows of carbon in water. Which brings me to water and hydrology. And there just needs to be more investment in this side of peatland science in the Central Congo Basin. And probably elsewhere, because peatlands are hypersensitive to the hydrology, to the amount of water and the amount of flooding, the amount of drought. So we need to monitor that much better with permanent monitoring stations, and then models to be able to predict what may happen in the future under different management plans. In the Central Congo Basin, we're using a model called Digibog, but HM-Trop, and there are a few others to monitor peatland development so that in silico, inside your computer, you can look at different management options and see what the implications are for your peatland before you do them in the real world. And finally, on biodiversity. Now, in the Central Congo peatlands, biodiversity studies are in the infancy, except for the large mammals. Now, in the Central Congo peatlands, particularly in the Republic of Congo, there are very high densities of elephants and lowland gorillas and some chimpanzees. And on the Republic of Congo, a DRC side, there are bonobos. And these are relatively well studied. But what we don't have is a kind of inventory of the biodiversity within these peatlands and how we can compare them to the tropical forest nearby and how we can compare them to peatlands elsewhere, particularly in Southeast Asia and in Peru. And I think the way to go for that is very standardized sets of measurements using camera traps, eDNA, and acoustics, where you can deploy identical technology in different places to be able to make comparisons on identical technology, so over time you can understand what the trends are in your indicators of overall biodiversity. But I think biodiversity science needs to focus a little bit more on these tropical peatlands. I have one student who's studying insects in the peatlands, and we are finding new species, new records for the region all the time, and also very likely new species. And I think if we have those kind of investments and investments in scientists from those countries to be able to make those measurements, then we'll be in a very good place to have the information available to much better manage these peatlands for local people and also for the wider global community. Thank you very much.
Thank you very much, Simon. Maybe before you leave, since you were maybe not able to stay to the end, maybe you could just let us know about how this work on the Congo and protection of the peatlands in the Congo can link to...
Can you
just indicate how the work in the Congo or protection in the Congo can link to the UNFCCC targets and the Global Biodiversity Framework targets. Thank you.
Yeah, thanks very much. One other thing I forgot to say is that we have a briefing on the CongoPeat.net website of called The Value and Vulnerability of the Central Congo Peatlands, which summarizes everything we know in terms of carbon, water, and biodiversity for these ecosystems. I think the peatlands are going to be very important for the Republic of Congo and the Democratic Republic of Congo meeting their targets under the Montreal framework, and also in terms of future nationally determined contributions under the UNFCCC. They are so important in terms of carbon. To give you an idea, there's as much carbon in the peatlands, covering around 5% of the Congo Basin, as there is in the other 95% of the tropical forests. So in terms of high carbon and high biodiversity, they will be important for both sets of both frameworks. Thank you.
Thank you very much, Simon. So I think we'll still try to keep within the Congo Basin. So let me call the next speaker, Dr. Ivo Suspense-Averti from the University of Mariam Ngupi from Republic of Congo, to share his views with us. Thank you.
Merci beaucoup pour la parole qui m'est accordée. Moi, je voudrais apporter ma contribution par rapport à cette session en abordant certains points qui, pour moi, sont très importants. Le premier point que je voudrais aborder, que nous sommes en train de vivre en direct, c'est le point concernant la définition de la tourbe et des tourbières et son impact sur la cartographie. En effet, nous le savons tous que différents pays, selon leur souveraineté et les objectifs qu'ils se sont assignés, ils sont arrivés à définir leur propre définition nationale, ce qui rend assez difficile la maîtrise de la superficie ou des étendues au niveau des différents pays, mais aussi au niveau mondial. Donc moi, je souhaiterais que le groupe des chercheurs au niveau international, que nous puissions travailler et arriver à un accord qui puisse permettre de faciliter on va dire la définition de la tourbe et des tourbières. Dans le cas des travaux de recherche qui ont été menés au sein de l'équipe CongoPeat où nous sommes membres, nous avons considéré une définition qui nous a permis d'aboutir à cette carte qui est aujourd'hui connue au niveau mondial. Mais il se trouve qu'il y a certains pays qui pensent que cette définition appliquée n'est pas la bonne pour elles. Elles veulent réviser des définitions et proposer d'autres définitions. C'est de notre responsabilité en tant que scientifiques de conseiller les décideurs et de les montrer quels sont les avantages ou les conséquences qui sont associés à la prise en compte ou à l'adoption de certaines définitions. Le deuxième point que je voudrais associer en lien avec ce point sur la définition, c'est que la notion de la ressource naturelle tourbière, elle est associée par rapport à l'étendue ou à la disponibilité. Si la cartographie n'est pas bien faite, vous n'auriez pas une bonne connaissance de l'étendue de cette ressource naturelle qui est la tourbière ou la tourbe, l'objet de notre réflexion ici. Et nous devons prendre conscience sur les implications qui sont associées aux inventaires des gaz à effet de serre, parce que de plus en plus, si nous considérons les inventaires des gaz à effet de serre, ces inventaires sont axés sur les émissions anthropiques et donc l'ensemble des activités anthropiques qui sont menées dans les zones de tourbière. C'est la raison pour laquelle, en tant que scientifiques, nous devons travailler énormément avec les décideurs politiques pour faire comprendre quelle est l'importance de la cartographie, parce que la cartographie vous donne des informations sur l'étendue et les données de terrain, comme venait de dire le professeur Simon Lewis, vont permettre, après calcul, d'avoir des données sur le stock et autres. Mais d'abord, avant tout, quelle est l'étendue de la tourbière? Alors, je voudrais aussi aborder un autre point très important, c'est que dans cette tourbière qui est la partie sol, se développe aussi de la végétation aussi. Il y a une publication récente qui a été menée en République du Congo qui propose plutôt une équation allométrique des palmiers qui se sont développés dans les zones de tourbière. Mais en République du Congo, par exemple, et dans la plupart des pays tropicaux, nous n'avons pas que des palmiers. Nous avons aussi beaucoup de tourbières forestières et donc la forêt qui se développe sur la tourbe. Il est important aussi pour nous de multiplier des parcelles permanentes ou des parcelles d'études sur le terrain dans les zones de tourbières forestières pour arriver à mieux connaître ou cerner la variabilité spatiale de la biomasse aérienne dans les tourbières forestières. Parce que nous parlons des émissions et nous savons que les émissions, pour les calculer, il faut avoir des facteurs d'émission, mais aussi il faut avoir des données d'activité. Les données d'activité, nous pouvons les avoir à partir de la cartographie, qui va vous donner des éléments sur les pertes. Mais en termes de facteurs d'émission, nous avons encore à renforcer les études sur le terrain pour améliorer notre connaissance des facteurs d'émission qui sont associés aux tourbières forestières. Alors, un autre point aussi très important que je voudrais aborder avant de pouvoir terminer ici, c'est que sur le terrain, nous avons noté ces dernières années, en discutant avec les populations locales, c'est qu'il y a une espèce de variabilité climatique dans certaines localités à tourbière. Il y a des zones où la saison sèche avait une durée de 2 mois, et de plus en plus, cette saison sèche tend à durer 3 mois ou 4 mois, ce qui donne la possibilité à ces populations locales de pouvoir pratiquer certaines activités agricoles. Et ce que je vous dis, c'est ce que nous avons vu, nous, sur le terrain, des populations locales qui ont compris que ce type de sol est très riche en matière organique et elles ont commencé sans l'avis même des experts, par elles-mêmes, elles ont compris que nous pouvons pratiquer un type d'agriculture dans ce type de sol. Nous avons vu des populations planter des aubergines, planter du maïs, planter de la tomate, parce que ce sont des produits qui ont un cycle végétatif de 3 mois qui correspond généralement à la durée de la saison sèche, à la période où l'eau se retire. Alors nous savons tous les conséquences du drainage pour la stabilité ou l'intégrité des zones de tourbière. Il est très important que nous puissions travailler à la sensibilisation, prendre en compte toutes ces données scientifiques pour que nos populations locales davantage connaissent c'est quoi la tourbière, parce que c'est un concept qui est encore mythique, réservé qu'aux experts que nous sommes. La plupart des populations locales ne savent pas c'est quoi la tourbe, ne savent pas c'est quoi la tourbière. Donc nous devons aussi travailler dans ce sens-là, parce que nous avons tous cette donnée scientifique que ce sont des zones qui sont très riches en biodiversité. Et je voudrais terminer en disant ceci. Avant de parler de la conservation des tourbières, il faut améliorer la connaissance de la biodiversité dans ces écosystèmes-là. On ne peut pas parler de conservation si vous n'avez pas une bonne connaissance ou maîtrise de la biodiversité à l'intérieur. Et lorsqu'on parle de la biodiversité, le professeur Simon Lewis a parlé des insectes, mais il n'y a pas que des insectes dans les tourbières. Moi, j'ai des collègues ichthyologues qui travaillent sur les poissons, qui m'ont dit que leur mission de terrain sur le terrain a montré qu'il y avait des espèces endémiques dans les tourbières. Donc, il est important que nous puissions financer la recherche, davantage financer la recherche pour que le dossier pour défendre la dimension de la conservation soit consistante, parce qu'on aura toutes les données scientifiques, tant au niveau de la faune, mais aussi qu'au niveau de la flore, et ce qui nous permettra de pouvoir défendre on va dire ce dossier vis-à-vis des décideurs. Merci beaucoup. C'est ça ma contribution dans ce panel.
Thank you very much, Ivo, for the very comprehensive remarks and the importance of mapping and identification of the characteristics and the species to help us with the management and engagement with the communities. Let us move on to our next speaker, Francesca Tanur from the Greifswald-Meyer Center will give us more an overview of some of the key issues related to peatlands globally. Thank you.
Thank you very much. I will be brief and I share a presentation. I think it will start in a minute, or maybe I can move it already? No. Now. Yeah, it's about the triple win, water, biodiversity and climate. And I would just like to raise again that we have this global peatlands assessment, which was produced last year. And I would still recommend everybody who is interested in peatlands actually to download it, to go to the UNEP's website, because it brings together really the best information we have at the moment on peatlands with country and regional chapters. It has been prepared by 226 contributors from all around the world, a lot of scientists, peatland conservationists from 51 countries, and you see some of them on the picture here, and also some of the authors actually in this audience. And a few key figures to share simply again, some of it was mentioned already, 488 million hectares of peatland globally, 600 billion tons of carbon stored in it, and of course it's good to compare it to other carbon stores in the world, very high carbon density. And also to raise, again, I mean, we are discussing tropical countries today. The largest peatland countries are actually boreal countries, but then also Brazil comes in, Indonesia, DRC, Republic of Congo, and Peru. So we have a lot of the total peatland area actually in tropical countries. One of the good news was, from this assessment, 88% of the global peatland area is still undrained. But it also means 12% are degraded and they are losing peat right now. So right now we have a lot of peat going up into the air as CO2. And one of the other key insights was also that every year we use 500,000 hectares of healthy peatlands at the moment. So on the one hand side, here, for example, in Dubai, we are discussing technical solutions, CCS, whatever. At the same time, we are losing a natural ecosystem that is actually sequestering CO2. The status of global peatlands is very diverse. If you look at different regions, from where I come from in Europe, we have done very well in degrading, destroying our peatlands, so we can basically share knowledge what not to do with peatlands. In other continents and regions, it looks still much better. I would also like to raise your attention to the global peatland map, and Ivo already mentioned, of course, for mapping, it matters very much what your definition of a peatland is. So we have a very broad definition in this map, which is published along with the global peatlands assessment. It's composed of a lot of independent data sets from different countries and regions, and it covers also organic soils and proxy data as well. What a recommendation actually and outcome of the global peatlands assessment was that we should include more peatland data starting with a peat depth of 10 centimeters. So in many countries actually 30 or 40 centimeters as a minimum depth are implemented in state procedures. This is not, I mean really, there's not really a scientific reason for it. So the 30 centimeters in Europe come from the depth of a plow basically. So that's why the one recommendation is indeed to go for the 10 centimeters, because also shallow peatlands matter a lot in terms of climate, in terms of adaptation and so on. So 3 more slides, one about water. We are currently working also on a peatland hotspot atlas. So we combine the peatland, the global peatland distribution data with other thematic maps. For example, cropland. On the top, you see cropland on peatland. This is, of course, then a big issue with respect to water. Water scarcity is increasingly problematic in peatlands. But wet peatlands can also help in times of water scarcity, of course. Because wet, undrained peatlands regulate and stabilize the landscape water balance. They can provide clean water, flood protection, and also evapotranspirative cooling. We have actually assessed these ecosystem services for temperate peatlands also along with the carbon credit that is on the market for more than 10 years already. But I would say these methods are still very basic, but there are very rough assessments available. And then the other map is urban areas, actually. Where do we have urban areas on peatland on the right-hand side? This is also, of course, an increasing issue in terms of water use and the amount of water that is available. And then biodiversity. So in this atlas, we will also propose a new map actually looking at species richness and biodiversity indices combined with peatland distribution data. So as a rough outcome, maybe northern peatlands are not the focus of peatland-related biodiversity. So the boreal peatlands, they are rather species poor. There's genetic diversity, of course, within the species, but really the subtropical, the tropical southern peatlands, they are much richer in biodiversity. They have a high level of endemism, and with increasing human encroachment, biodiversity is declining rapidly in some regions. So we know in some regions still little about it, and we are losing it at the same time. And then climate as the third layer or dimension. I mean, we have the link to the G20 today, and I was just looking up the figure, the number, I didn't really find it, but I believe it is some 80% of total global emissions that come from G20 countries, actually. So these are the big emitters, so to say. We have 2 billion tons of CO2 equivalents emitted from drained peatlands annually. The biggest ones, the biggest emitters are Indonesia, but we also know that Indonesia is doing a lot about it to actually decrease the emissions. We have Russia with 12%, and then the European Union also with 12%. And I can say for my country, we have ambitious plans, but we are lagging behind Indonesia, I would say, in terms of speed of restoration. Yeah, and more attention is needed. And a last slide maybe about paludiculture. Maybe we can touch on it in the discussion, because that is a way of wet land use agriculture or forestry on wet peatlands. My institution does a lot of research about. We are now starting 9 large-scale paludiculture projects in Germany on several hundreds of hectares. This is one of our study sites, a 10-hectare cattail plot in a drained peatland. And there's a lot of interest in it. We even had a company from UK getting cattail from us to use it for producing clothes, actually, from it. There's a wide range of paludiculture species. There's a database on it also. And of course, just as one example here, there's a house. For building such a house, you can do actually a lot of it from peatland plants. The same would be for such a pavilion. You could perfectly build such a pavilion, most of it actually from peatland plants. So maybe at any COP in future, we will sit in a pavilion made of paludiculture material. Thank you very much.
Thank you very much, Francesca, for the global overview and presentation. Let's move back down to the ground, and we're going to have a presentation from Indonesia. Ms. Nika Putri, from the Forest Carbon Sink Business Department of Sumitomo Forestry, will share potential methods on carbon emission and biodiversity evaluation in tropical peatlands. The floor is yours for 5 minutes. Thank you.
Okay, thank you. So good afternoon, ladies and gentlemen. My name is Niken. I'm here to represent Sumitomo Forestry and also Mr. Suyoshi Kato, my supervisor, who unfortunately could not make it to join us today. And in this opportunity, I would like to share our view regarding the potential method on carbon emission and biodiversity evaluation in tropical peatland based on our experience working on tropical peatland in West Kalimantan, Indonesia. So tropical peatland cover more than 100 million hectares, distributed mostly in the Southeast Asia, the Central Congo Basin, and also the Amazonia. But the data about it is still very limited. And the good news is that Sumitomo Forestry has been given the opportunity to learn about tropical peatland management by managing several plantations in West Kalimantan, Indonesia. And before starting the operation, we have collected many data to enable us making a proper model to achieve sustainable peatland management. And since 2009, we have conducted ground survey and data collection, including a topography, groundwater level, and others. And this data collection still continue today, resulting in a huge peat data sets. And first, I would like to talk about CO2 emission evaluation method. I will skip this part because maybe most of you has known about this. And then this. So basically, there are two approaches for tropical peatland management for estimation CO2 emission. But today, I would like to focus on CO2 emission estimation based on ground surface changes monitoring. And we have collected, we have estimated carbon emission from tropical peatland by using the ground and remote sensing data such as SAR satellite and also the drone images. And the result of both methods are as follows. First is from photogrammetry. So using this approach, the peat subsidence is estimated by subtracting terrain information from between two different periods over the same areas, and the elevation data was taken using VTOL UAV with RGB camera and RTK, and then the result were compared with the ground survey measurement in 5 different profiles. And by calculating the peat volume loss from the peat subsidence, the carbon emission is estimated about 25 tons CO2 per hectare per year. And the second is using the satellite data. So interferometric SAR or INSAR combines 2 different satellite images over the same region for measuring the changes in topography or surface motion. And in this estimation, we use ELOS Pulsar 2 from 2020 to 2023. And the result was then compared with the ground data taken using the displacement method. This sensor is recorded the ground surface level changes in response to swelling and shrinkage in the hourly basis. And by calculating the volume, the peat volume loss from peat subsidence data, the carbon emission is estimated about 23 tons CO2 per hectare per year. And to date, we are still exploring any other way to improve the accuracy of this both method and to add more ground data that evenly distributed in our concession area. And next is about biodiversity evaluation method. Okay, so I'll just skip this, and this is what we have done. So we measure the biodiversity, including direct measurement, the use of camera trap, and also thermal drone. And in the left picture is some biodiversity found in our concession area. And to conclude, we see that at least 3 aspects we have to consider in regard to evaluation of tropical peatland. The first is by combining the remote sensing and intensive ground data to enable a more accurate MRV system, and the need of proper peatland water management that enable us to significantly reduce the CO2 emission. And the last, we believe that the richness of the biodiversity is determined by the size of the box that holds it. In other words, the bigger the box is, the richer the biodiversity and also carbon stock. Yeah, thank you very much.
Much. Last but not least, I have great pleasure to introduce my close friend, Muhammad Ascari, Deputy Director for Control of Peatland Degradation from the Ministry of Environment and Forest of Indonesia, to give a summary of Indonesia's very major achievements on CO2 emission reduction from peatland management. Thank you, Pak Ascari.
Puan-puan, tuan-tuan, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Have a very good afternoon, good morning, good evening, depending on where you are right now. So, because I have many slides, I will try to run as quick as possible without losing the information. Okay, the first one, I would like to share with you the challenge that we have so far. There has been more than 41 million people who live in the peatland area in our country, Indonesia. 41 million. So you can imagine, I mean, the pressure that we have so far. We have 24.6 million hectares in the PHU area. I think this is the problem that we have if we drain the peatland area. We have a huge dryness in our country. That's come to the challenge. This is just giving you the example, the picture. Because we drain all of the pits, now it's easily to be burned. That's a big challenge because 41 million, it's not easy to educate 41 million. Particularly the people with the low education level. So that's a very bad condition. But what we have done so far, we try our best until now, until I'm speaking today, that we have restored more than 3.7 million hectares of the concession area, restoring the hydrological function, putting back the water. And also we have installed for more than 28 canal blockings. This is in the concession area. For the community area, 15,000 that we have done so far. So that's why we enjoy that, even though that this year we have a longer period of the El Nino comparing 2019, but the forest fire is about less than 40%, about 38, if you compare to 2019, even though it's longer. I mean the period of that. And in the community area also we do our job, I mean how to do restoration. This is some of the example, I mean this is from the company, also from my colleague here. So we go there, we look to the field, we try to improve everything. We bring back the water because 90% of the peatland is water. This is some of the construction you can see from the sky, from the Google Earth, because we have done that in the particularly in the 1 million hectares mega-rise project, so that we put back everything. We try to restore everything there, even though that's come to a huge challenge for us until today. Okay, this in the community area with the spillway, because some communities still use that just to do for fishing and many others. This is the information that we have, a system that we have so far. You can see there, the red color there, that means the canal blocking. We put thousands of canal blockings. And then the blue dot, that's the water monitoring level, to monitor the compliance point. We have more than 10,000 compliance points all over Indonesia. So now that easily for me, straight away right now that I can monitor the water level here, just using the handphone. This is a real-time one. So we have a huge database on this one because we would like to make that everything can be managed. This is just an example. Thank you for the FAO for supporting us for the soil moisture content. We have this map to see whether we do our job is right or not. You can see here directly the much more blue color, that means much more soil moisture, much more wetter. You can see because we put the canal blocking, so the area is much more wetter. That's the idea behind. So now we already have this one. And also that we have the regulation in our country that the water level should not exceeding 0.4 beneath the pit layer. At the time, at the initial phase that we are opposing by particularly maybe a colleague from the private company. No, all of the plant will die. The root will rotten. That's what they said. But now we can prove it with the more than 10,000 data that we can achieve the 0.4. You can see there, 31, 34. This is the average of the groundwater level within 1 year, fully 1 year. Okay, this is the all. Okay, this is just the figures that we have so far. The time when we are developing the regulation in our country, we use this publication to determine 0.4 below the groundwater level. You can see there the correlation between the groundwater level and also the hotspot. That's in Kalimantan. This is the comparison of the area, which is the burn area, which is comparing 2000 to 2019. Yeah, it's much more lower. And this is the comparison. Okay, thank you, Faisal. Okay, so I'm running. What I would like to also share with you that through the research that we have, the latest research that we have, just to do the water management only, that we can improve the productivity of the fruit bunch in the oil palm plantation. Just water management. Because where's the fruit bunch coming from? The reaction between CO2 plus H2O. We drain this H2O. It's not possible to make a fruit branch. So we have this data. We can improve until this one is 13%, this one is 30%. Just by using the water management level. You can see down there the groundwater level. And also that if we we conserve the area, so this is, I'm comparing the area, one of the PHU, that the water volume there is 2.1 million meter cubic. If we drain this one, it's equal to, if we drain this one of the largest dam in our country. So huge number of water, which is storage in the PHU, in the one PHU. So if we damage it, how many investment that we have done? Okay, I'll skip this one, this from colleague. Now that, how about the carbon emission? So we'd like to ask the international community to help us in the peatland area, because we have done this much data, and we have this publication through Nature. This is the correlation between the groundwater level and also the CO2 emission. By using this equation, so we can calculate easily for us in Indonesia, through the water management that we have done so far, within 3.7 million hectares, that we have reduced the CO2 emission 150 ton CO2 equivalent. Come to the equation that we have so far. Okay, and that also that has been in the NDC, net following. We have also the information system. I think this is maybe one of the, you can open it directly, so you can monitor. As I said, that we can monitor easily. Okay, this is a system, just to show you. This is my closing statement for this session, that on behalf of Indonesia, if I may use, because I'm, this is on the ITPC, Republic Congo, Peru, we asked to the global experts, international science community, and the GPI, of course, to pull all the resources and support in accelerating agreement on a correlation between the peat groundwater level and greenhouse gas emission. And I end with the big smile from the people who live, the kids who live in the peatland area, because there's a new hope from our effort. Thank you very much. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Very much. Ascari. So can I ask the speakers to join me here, and then we will respond to any questions from the audience or highlight other issues. I think we're still awaiting the arrival of the Deputy Minister. Okay. I'd like to welcome Deputy Minister Pak Alu Dahong of Ministry of Environment and Forests. We will have a short 5-minute round of Q&A for the panel members, and then we're delighted to have some closing remarks from Pak Alu Dahong, the Deputy Minister of Environment and Forests of the Government of Indonesia. So let me open the floor. Are there any specific questions would like to ask? Yes, please.
Thank you so much. I'm Nanami from Japan. And yeah, thank you so much for your very informative, fantastic panel, and merci beaucoup de votre présentation. My question is about related to economic, I understand the importance of peatland, but who do you think plays the important role to provide finance? Like there are sovereign bond, or carbon finance, or private sector investment, something like that.
So thank you very much. Maybe Francisca, maybe you can respond about what you think are the key finance sources that should be tapped to support peatland management.
Yeah, maybe this is not all fully applicable to tropical countries, but from my perspective, for Europe, I would say the governments are needed because it was also government-driven that the peatlands were drained. So I see a lot of responsibilities there. And then you would probably also separate between the costs of revetting and the costs of maintenance after it, because at the moment, wet soil loses value, and this is, I mean, conceptually also a problem because it is a carbon store, but at the same time it's less valued. So we need to change also the laws to some extent. And so either the revetting comes from state funds to achieve climate goals, or you can possibly use carbon credits for revetting activities. So there is growing initiatives around. And then you have to differentiate between emissions avoided and additional removals of carbon. And then the maintenance actually, so we think about combining it either with tourism, with wilderness areas, but also with renewable energy. So on strongly degraded peatland, maybe the combination with solar energy could be an option. And then paludiculture is of course an option also to provide benefits for farmers and for landowners.
Thank you. Are there any other questions from the audience? If not, let me ask Evo. What is, from your perspective, what is the key step that need to be done to protect the peatlands in the Congo Basin?
L'étape la plus importante, selon moi, consiste d'abord à arriver à sensibiliser les décideurs politiques, à impliquer de manière effective les décideurs politiques afin que sur l'ensemble ou dans l'ensemble du bassin du Congo, donc l'étape la plus importante consiste donc à sensibiliser les décideurs politiques, premièrement pour que les décideurs politiques puissent davantage s'impliquer sur ces questions de protection des tourbières. Et la deuxième étape la plus importante, qui pour moi peut-être aussi devrait être la première, mais je pense que c'est la deuxième, c'est qu'il faut passer à l'étape de la sensibilisation de la communauté nationale et plus particulièrement des populations qui habitent dans les zones de tourbières. Tout à l'heure, j'ai suivi l'expérience de l'Indonésie. J'ai compris qu'il n'est pas facile de pouvoir sensibiliser des millions de personnes en quelques secondes, en quelques jours, et surtout que tout le monde n'est pas toujours accessible. Mais je pense qu'il faut utiliser différents moyens de communication pour atteindre le maximum possible de population. Troisièmement, c'est l'étape juridique. Il faut arriver à mettre en place des instruments juridiques assez puissants, voter des lois au niveau de l'Assemblée nationale, voter des lois au niveau du Sénat qui puissent donner un sens juridique à la protection de ces zones de tourbières. Pour que lorsqu'on va passer à l'étape de l'aménagement du territoire, que la dimension de la cartographie des tourbières soit prise en compte et que les terres ne soient plus affectées pour des projets qui vont affecter ou dégrader les zones de tourbières.
Okay, thank you very much. Sorry for the inconsistent translation support, but I think the key thing is important to raise the understanding, both of the local communities in the peat, but also the broader stakeholders, and to draw on experience from other countries such as Indonesia, which have a rich experience in peatland management, and share that with the stakeholders, and that can help overcome some of the challenges to peatland management in the future. So finally, for the panel members, before we come to the closing, let me pass to Pat Ascari. And again, just a few words about, from your perspective, and what you have seen what are the key next steps that are needed to protect or continue or expand the work for better peatland management in Indonesia? Thank you.
Okay, thank you very much. So basically that we know the peatland is a very precious resources. So we need to keep it, not just for Indonesia, but also from the global point of view. That's why we ask, we need a collaboration. Maybe that can be sharing of the knowledge, sharing of the experience, and also maybe some other modality that can be shared through many ways. We have spent our national budget, of course, in the do the restoration, but of course that will be, if it's possible, that we have another sources maybe from other of Indonesia, because this is a very important ecosystem. So we need other international community to support it. And also include about the methodology, because if we come to the agreed methodology, it will be easier for us to claim, to calculate easily, because sometimes that we know that the data is big one, the data is a small one, something like that. So we need to come to the agreed methodology. Thank you.
And last but not least, Ms. Nikin, maybe you can highlight what role the private sector can play in better management of peatlands.
As a private sector myself, firstly, we would like to give support from the government or other sector, and we believe that to promote these, to promote more sustainable peatland management, private sector need some incentive in terms of carbon credit or biodiversity credit or others, and that way we can expand the proper peatland management and to achieve the sustainable peatland management. Yeah, thank you.
Thank you very much. Thanks again to the panel members for their contributions for the session. Maybe the panel can take their seats and then we will proceed to the closing remarks. Thank you very much. So for the closing, it gives me a great pleasure to introduce my dear friend, Pak Alo De Hong. 20 years ago, he and I were in the peatland in central Kalimantan in the middle of the biggest canals ever constructed in the peatlands in Indonesia, struggling how to block those canals and raise the water level and stop the fire. And very happy that 20 years later, such success has been done, and Pak Alo himself is now elevated to the Vice Minister of Forestry, overseeing the policy and the peatland rewetting for the whole country. And so we're greatly honored that you have come here today to join us and to give your closing remarks for this event. Thank you very much, Pak Alo.
Thank you, Pak Faisal. Distinguished speakers, participants, ladies and gentlemen, this is my great honor to be here at this event entitled Enabling the Triple Wins for Tropical Peatland Countries Advancing Water, Biodiversity and Carbon Measurement, that just we heard from numerous of speakers with different geographic, different state of information and research or information about peatland in their respective region. I think I don't need to explain more about peatland. Everyone here, I do believe that we all understand about the roles of peatland, yeah, in terms of economy, ecology, societal, including biodiversity and its roles for the climate change. And what we draw from a couple of presentations we just heard in this event, we see that from the global perspective, the global assessment of peatland has been done. And some of the countries, like Congo, DRC, of Congo Republic, from Congo Basin, and from Indonesia, in particular also practical from the companies to do a peatland management in their respective concession. And yeah, you can see, still some in the preliminary information, some already at the advanced state, some even, more progressive in terms of not only inventory, but also action related with restoration and so on. And even the use of technology to do the monitoring of the, land use change, conversion, drainage, as well as restoration action in the peatland areas, in the tropical, in the boreal, and also including into the temperate. We can see, progressive development. However, while we recognize the importance of this tropical peatland, boreal, and temperate peatland, to bring, again, I just to remind all of us that to bring up these masses to the high level negotiation, like to the high levels, even as this conference of the parties of the UNEP policy, still, huge concerted action and collaboration need to be done. Yeah. Otherwise, we just talk about peatland, its problem and so on, but we lose the opportunity to use peatland, for example, to protect climate, to protect biodiversity, and also to protect the livelihood of the local people. And I understand that from the, climate change perspective, I think we had a session in the Indonesian pavilion like 2 days ago, yeah, Pak Faisal, and Professor Osaki, one of the speakers of the session. We recognize that, before we come up with how much money we can get it, how we can get this carbon money and so on, there are also substantial effort that we need to review. For example, we have this 2013 supplement to the 2006 IPCC guideline for the national GHG inventories for wetlands, for example. This kind of old supplement we need to be revised, need to be updated, because so many research have been done, in particular in the tropical peatland, like in Indonesia, Malaysia, Congo, DRC, Republic of Congo, Brazil, and so on. And as we recognize in this 2013 supplement to the 2006 IPCC guideline, they still use a very raw and limited research from mostly boreal and temperate peatland, right? And just very limited from tropical peatland. With this kind of now, huge research, including by the universities in tropical and peatland, including by the companies who implement this kind of, like Sumitomo just presented to us about how they implement this kind of hydrological management with their concession, in their concession, and they manage to reduce, for example, emission from oxidation or subsidence or whatever, also from fires. So we need to revise this IPCC guideline, and we do need to work together. I mean, from tropical peatland scientists, government, and so on, NGOs including, to work hand in hand to develop a new methodology, the recent methodology, in order to get precisely or proper emission factors from activities on a peatland. If I talk about activities, that means land use activities. water management activities, fire prevention activities. So we can come up with precisely emission factors and we submit it to the IPCC panel to accept that, to revise this 2013 supplement of the to the 2006 IPCC guideline for GHG and national GHG inventory for wetlands. Because if we aware in that supplement, they just tier 1, yeah? That's very macro. Tier 1 is very macro. And all those kind of research actually already tier 3, very detailed, right? So we based on that, we can revise this. And also we can add some of the activities because in that IPCC guideline or supplement, they just talk about drainage, inland organic soil, reverted organic soil, coastal wetland, inland wetlands in mineral soil, constructed wetland for wastewater, but how the others, other land uses, like managing of hydrological or water management within the concession, within the commodity lands, within the other land uses type. So we need to do that as soon as possible. I just convene all of us to work together about this. From Congo, Congo Basin together with scientists. I know Simon Louis already left, He also good. You also, Ito, is it the right name? Ifo, sorry. I think we met twice or 3 times already, in Brazil, in Indonesia too, right? So we have to do it together, right? So once we have all this kind of precisely emission factor, so once we do something on the peatland, type of activities or land use activities on the peatland, and we can calculate how much emission that we can avoid it, or how much emission that we can sequester through this kind of tree planting on peatland, how much emission that we can avoid it from putting all this kind of rewetting infrastructure on the ground. And once we got this kind of information and put into the web-based or whatever with the new technology of the database system or web-based database system, and we develop a Murphy system or methodology that I think I really convince us to check what Professor Osaki submitted, proposed, during 2 days ago about we can use this approach of net ecosystem emission, whatever you call it, and the second one based on, I can't recall it, the second one, but that's one of the particular that we can develop together, right? And make it real and submit it again to the IPCC to revise the supplement of the 2000 IPCC guideline for GHG, national GHG inventory for wetland. So this is the start of the working. We don't need to do more research. I mean, research is okay to fill the gap, right, between this kind of geographical areas. I mean, the yearning gap of the information between these geographical areas, but we need also to work as soon as possible to revise this emission factor. So if we talk later about how we can use carbon market mechanism for restoring peatland, for example, or we can use this kind of offset, carbon offset activities in the peatland for other outside, land use activities, for example, we can do it, right? And even we can promote, the new financial mechanism, including put this biodiversity that people just propose like a biodiversity credit or something like that. So that's all from me, and I really appreciate this kind of a very productive event or discussion, and looking forward to work with you all in the future to address our peatland. Thank you very much for your attention.
Thank you once again.